Hello to all my viewers. This is Dr. Dhaval Maheta, and today we are going to understand how to run one-way repeated measures ANOVA, that is, within subjects ANOVA in SPSS. So, one-way repeated measures ANOVA is a statistical technique used to analyze the data where the same subjects are measured multiple times. That is, the measurements are taken at more than 2 timestamps under different conditions. This method is particularly useful for studying changes over time or the effects of different treatments on the same group of subjects. Let's try to understand this concept in the next slide. We want to study the effect of weight reduction treatment on the subjects. So for this, we consider 3 time intervals T1, T2, T3. Remember that the weight of the subjects are to be taken at the 3 timestamps. Weight at T1, weight at T2, weight at T3. So you can see there is no significant change in the weight, and therefore our conclusion will be weight reduction treatment is not effective. Let's take the second case. Weight at T1, weight at T2, weight at T3. So the weight reduction treatment is effective. This is known as within subject variable where the element considered is time. Let's take another example. You might want to measure the weight of the subjects 1 month before they start a training program. That is the baseline weight. During the middle of the training program, that is after the completion of 4 months, and after the completion of 8 months, to see if there is a significant difference in mean weight across these 3 time points or not. So the subject, the baseline weight after 4 months and after 8 months. So the weight of the John will be taken at T1, T2 and T3. Similarly, this will be repeated for other subjects also. Now there are some hypotheses which we will test in this case. We start with the research question. Does a new training program affect weight over 3 different time points or not? Dependent variable is weight. Independent variable is time points. That is, before the training program, the baseline weight, 4 months into the training program, that is after the completion of 4 months, and 8 months into the training program, that is on the completion of 8 months. The null hypothesis HO is there is no significant difference in weight across the 3 time points. HO, we can write in this format also, mu1, that is the mean weight at time T1, mu1 before training, the baseline, is equal to mu2 after the completion of 4 months, mu2 after the completion of 4 months equal to mu3 after the completion of 8 months. So we want to say that the weights are equal and there is no effect of the training program. Alternative hypothesis. There is a significant difference in weight in at least 2 of the 3 time points. I will explain this also. The alternative hypothesis can be also written as H1, at least one pair of time points has a different weight. So the weight at T1, weight at T2. So the difference can be in between these two weight, that is T1 and T2. It can be, the difference in the weight can be in between T2 and T3, or the difference in the weight can also be in between T1 and T3. There are some assumptions which we will have to test. We start with the univariate assumption, the assumption of normality. The dependent variable should be approximately normally distributed for each condition, time point and treatment. The assumption is particularly important when the sample size is small. With large sample size, the ANOVA is more robust to the deviations from the normality. The example of the normality is the distribution of the blood pressure readings at each time point, T1, T2, T3, should be roughly normally distributed. So we require normal distributions at all the 3 timestamps. So we are having a formal testing methods. Shapiro-Wilk test and Kolmogorov-Smirnov test is used for the testing the normality. If we are having a small sample, we go for Shapiro-Wilk, and for the large sample, we go for Kolmogorov-Smirnov test. The second assumption is of the sphericity. The sphericity assumption, also known as the homogeneity of the variance, is meaningful only if there are more than two levels of within subject factors. We are having that, more than two levels, T1, T2 and T3, and that's the reason we require to test the sphericity. The variances of the difference between all the combinations of the related groups condition should be equal. Example of sphericity. Let's repeat the same example of the blood pressure. We have taken the blood pressure of the patient before the medication, 1 month after the medication, and 3 months after the medication. So what we want that the difference in the blood pressure readings between, I'm talking about difference in blood pressure readings before medication and 1 month and 1 month after. Then the second difference is before medication and 3 months after, and 1 month after and 3 months after should have a equal variances. That is sphericity. Let's take one more example to make you understand what is the assumption of sphericity. A layman example. Imagine you are trying 3 different types of ice creams with your friend. You want to know which one they like the most. The ice creams which you consider for this are vanilla, chocolate and strawberry. Friends have to give the rating. Each of your friend tastes and rates all the 3 ice creams. Understanding the sphericity. Consistent difference. Sphericity means that the difference in how much your friends like each type of ice cream should be consistent. For example, if one friend likes vanilla more than the chocolate by 2 points, other friends should have a similar difference in their ratings. See, the individual rating can be different, but if I talk about the differences, then it should be equal. Why it is important? If the difference in ratings are not consistent, it can be hard to tell which ice cream is actually the favorite. For example, if one rates vanilla 10, chocolate 8 and strawberry 6, the difference between vanilla and chocolate, vanilla and chocolate is 2 points. If another friend rates vanilla 6, chocolate 9 and strawberry 8, the difference between the vanilla and chocolate is 3 points. So you can see here the assumption of sphericity is violated because the differences are not equal, or in other words, the differences are not consistent. Now let's say friend 1 gives a rating to the ice creams as 8, 7, 6. Friend 2 gives a rating as 9, 8, 7. Friend 3, 7, 6 and 5. To check for sphericity, we'll look at the differences between the ratings for each pair of ice creams. Difference between vanilla and chocolate. 8 minus 7, 1. 9 minus 8, 1. 7 minus 6, 1. Difference between vanilla and strawberry. 8 minus 6, 2. 9 minus 7, 2. Friend 3, 7 minus 5, 2. Difference between chocolate and strawberry. 7 minus 6, 8 minus 7, 6 minus 5, 1. So the differences are consistent for vanilla versus chocolate, for vanilla versus strawberry, for chocolate versus strawberry. This means that we have achieved the sphericity. Sphericity means that the difference in the ratings between all pairs of ice creams should be about the same for everyone. When this happens, it is easier and more accurate to find out which ice cream your friend likes the most. If the differences are not consistent, it becomes harder to figure out the true favorite. So we are having one test, that is a mock list test of sphericity to test the assumption of sphericity. This is a primary test used to check the sphericity assumption. It assesses whether the variances of the difference between the conditions are equal or not. If the differences are not equal, no need to worry, we are having a correction factor also. So if mock list test indicates the violation of sphericity, corrections like greenhouse gases are applied to adjust the degree of freedom. The next assumption is of the independence of observations. The observations should be independent of each other. This means that the score of one subject should not be influenced by the scores of the another subject. The example is the blood pressure readings for one participant should be independent of the readings for the another participant. Now we don't have any formal test to check the independence of observations, but this we can achieve with the help of study design. The independence assumption is primarily addressed through the study design, ensuring that the ratings or measurements of one participant do not influence those of the another. No specific test is generally used to check for independence, but it is critical to ensure and we should achieve the independence of observations. This can be done by proper randomization and control in the experimental design. Now let's take one case study. 8 individuals, 1, 2, 3, 4, 5, 6, 7, 8, participated in a study aimed at reducing the cholesterol levels through various intervention strategies. Each participant had an initial cholesterol measurements recorded at the beginning of the study, that is T1, the cholesterol test, the levels of cholesterol at time T1. Then the measurements were taken at 3 time interval T2 and T3. T1, that is the starting of the intervention strategy, T2 and T3. We want to see is there any significant decrease in cholesterol levels or not. Some hypothesis which we are going to test is there is no change in cholesterol over time, null. Alternative, there is a significant change in cholesterol over time. This is known as within subject variable effects. The element is time. So let's go in SPSS. The same sum is here. So now we will go and analyze. Generalize linear model, not in models, generalize linear model. Activate repeated measures. Now write down here time. How many levels are there? 3 levels are there, T1, T2 and T3. Press add, define. Test 1, time period 1. Test 2, time period 2. Test 3, time period 3. Click on model, keep things as it is, no change. Continue. Click on contrast, no change, keep as it is. Click on plots, transfer time into the horizontal axis and press add. Line chart should be activated. Continue. Post hoc, nothing is there, no need to worry. Continue. Estimated marginal means, transfer time here. Compare the main effects, keep LSD on. Continue. In save, no change. In options, descriptive statistics, estimates of effect size and homogeneity test. So 3 ticks are to be done. Continue. Click OK and you got the result. So this descriptive statistics interpretation we will see at the last. First we start with the assumption testing. So the first assumption which we have to test is the mock list. The first assumption which we have to test is the sphericity. This can be done with the help of mock list test. So I will click here, right click here, copy. I'll take it in the PowerPoint and let's do the interpretation. What is our null hypothesis? The null hypothesis is there is no significant difference in the variance of the cholesterol at 3 time points. Just recall the sphericity assumption, the sphericity slides. In simple language, data is having the sphericity. See the value of mock list, that is 0.565. See this value, 0.180. Normally the mock list W, this value should be nearer to 1 to achieve the sphericity, and this value, the p value, should be more than 0.05 to achieve the sphericity. Let's do the interpretation. The p value is 0.180, which is greater than the typical significance level, that is typical significance level of 0.05. This suggests we fail to reject null hypothesis of sphericity. We fail to reject. So at the back of the mind, you should remember we are accepting the null. So desirable is the p value should be more than 0.05 so that we can accept the null and the assumption of sphericity is not violated. In other words, the assumption of sphericity has not been violated, which is desirable. So what is desirable? I will repeat. This value should be nearer to 1 and this value should be more than 0.05. Let's proceed further. This table, you will get it from here. Test of within subjects. Here is it. Right click, copy, and let's do the interpretation. Sphericity assumed. So in the test of within subject effects, I'm talking about this table. When we fail to reject null hypothesis, so the previous case, the mock list test, when we fail to reject null hypothesis, that is the assumption of sphericity is not violated. Sphericity assumed the effect of subject is to be done from the first row. So we are considering this p-value to see the effect of subject when the sphericity assumption is not violated. So in our case, it is not violated. The second possibility, in the test of within subject effects, when we reject null hypothesis, that is the mock list test rejects the assumption of sphericity, that is the assumption of sphericity is violated, effect of subject is to be done from the second row observation. It is a correction of sphericity known as greenhouse geyser correction. But as in our case, we have achieved the sphericity, we will do the interpretation from the first row. As in this case, sphericity assumption is not violated, we consider the first row. The p-value in first row is 0.00, so we reject null hypothesis, which means that there is a significant difference in cholesterol at different time points. Next, we have to see eta square. So this you can get it from here. Both this table are available here. 1 and 2. You have to see this eta square. So in the first row, the eta square is 0.787, and in the factor 1 linear model, this is for linear model, it is 0.802. Let's do the interpretation. Partial eta square, it's just like your R square. Partial eta square provides a standardized measure of effect size ranging from 0 to 1. Values closer to 1 indicate that a larger portion of the variance in the dependent variable is explained by the independent variable or the contrast. In test of within subject contrast, linear p-value is 0.001, 0.001, this one. So we reject null hypothesis. Moreover, partial eta square value has also improved from 0.787 to 0.802. From here to here, it has improved. It means that 80.2% of the variability in the cholesterol level is explained by the linear function from time t1 to time t3 and is also statistically significant. Let's proceed further. Pairwise comparison. Now we have to compare that the difference in the cholesterol is in between T1 to T2, T2 to T3. Just recall the slides. Okay. So from where I can get this table. So here is it. Pairwise comparison. Cholesterol at 1 compared the mean cholesterol at time 1 compared with mean cholesterol at time T2 and time T3. So we will do the interpretation. Now you have to see the p-values of this. Mean cholesterol at time T1 minus mean cholesterol at time T2. The difference is 78.5 and the p-value is 0.001. The mean cholesterol at time T1 minus mean cholesterol at time T3. The difference is 89.375. P-value less than 0.001. Sorry, it's less than 0.05. Then mean cholesterol level at time T2 minus mean cholesterol level at T3. It is 10.875. This value is more than 0.05. All above values were less than 0.05. So comparison difference between time T1 and T2, the mean difference is this. So it is significant because the p-value is 0.001. This one, T1 and T3, 89.375. The difference is significant. But when we talk about T2 and T3, this and this, it is 0.243, and therefore the difference in the cholesterol level is not so significant. The difference is there, but it is not so significant. Now, when you compare 1 with 2 and 2 with 1, the difference is only in the signs. The p-value remains the same. So you don't need to compare it again and again. So what is our interpretation? There is a significant difference in cholesterol levels between time points T1 and T2. This T1 and T3, right? However, there is no significant difference in cholesterol levels between T2 and T3. You can see here, the difference is not so large. This is a post hoc test. Now we will also get the plot. This is available here. Right click, copy. Let's do the interpretation. The cholesterol level at time T1, the mean cholesterol level 178, at T2 99 and T3 88. If you take the difference of T1 and T2, right, what do you get? This figure, T1 and T2, you get this figure 78.5. When you take the difference of T1 and T3, you get this figure 89.375. Okay, when you take the difference of T2 and T3, 99 and 88, roughly it is 10. This is this one, 10.875. Okay, so the cholesterol levels have considerably reduced from T1 to T2, right? But it has not reduced considerably from T2 to T3. Okay, the drop is not so large. A decrease in mean value from initial levels would suggest a positive response to the interventions, or in simple words, the intervention treatments are successful in lowering the cholesterol level significantly. So this was all about one-way repeated measures ANOVA in SPSS. For more videos on advanced data analysis using at SPSS, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.